Students, today I am going to discuss the most important topic of this unit or this module, that is chain rules. These are rules which help make us convenient to find the partial differential of many special type of functions. In the previous classes we discussed the concept of partial derivation, first order derivatives, second order derivatives, and one or two theorems including the Laplace's function. Now from this class onwards, or from this video and coming 2 or 3 videos, we will be discussing the most important topic. This is the most important topic in the study of partial differential. Actually, according to our syllabus, this is the most important topic of our syllabus, and it has wide application in many problems. Direct as well as indirect applications are there for, or this is a method to find partial differentials, and it is used in many problems including mathematical physics, statistics, everything. So the topic of today's discussion, or the discussion in the coming classes, will be based on the topic chain rules. There are 4 or 5 chain rules. You have to understand the idea behind or the structure behind this chain rule, and you should be able to apply this in any physical or practical problems. Now today I will be discussing 2 types of chain rules. So the first one is that you are given a function w equal to f of xy. W is a function of 2 variables x and y, and x is a function of single variable t. This is my first type of chain rule, first chain rule. W equal to f of xy, x is a function of t, xt, and y is another function of t. So w as a whole, you can see only x and y, but this x is a function of single variable t, and y is also a function of the function of single variable t alone. So this will be our diagram. F of xy is a function of x and y. X and y are functions of a single variable t, and in effect, what happens to w? W becomes a function which solely depends on the single variable t, even though it appears to be in the form of x and y. X and y are basically functions of single variable t. So in effect, w becomes a function of single variable t, though you see it in the form of x and y. So as w contains only single variable t, you can find the total differential of w with respect to t, because w, xy and xy are in terms of t, so w is actually in terms of single variable t. So you can find the total derivative dw by dt. It is the actual differential, not partial, because w contains t alone. So the total derivative dw by dt is given by the formula dw or df by dt. Df, you can write this as df by dt. W is not required. You can write df by dt or dw by dt. Both are the same because w equal f of xy. So df by dt equal to dou f by dou x into dx by dt plus dou f by dou y into dy by dt. Now look at this diagram. F is a function of f, or w is a function of x and y. X and y are functions of the single variable t. So there exists only one variable in the base level, that is t. So we can find the total derivative dw by dt or df by dt. This is the same as dw by dt. dw by dt equal to df by dt equal to dou f by dou x into dx by dt plus dou f by dou y into dy by dt, because f contains x and y, and x and y are functions of t. So first we differentiate f partially with respect to x into dx by dt plus differentiating f partially with respect to y into dy by dt. Now if the given function has 3 variables x, f, x, y, z, that is f of x, y, z, w equal to f of x, y, z, and x, y as well as z all are the function of single variable t, the same case arises. That means w is containing only a single variable t, but the w appears to be in the form of x, y and z, but x, y and z are basically functions of the single variable t, that is w equal to f of x, y, z, and x equal to xt, y equal to yt, z equal to zt. Again you can find the total derivative. The only thing is that you have 3 variables in this stage, w equal to f of x, y, z. So you can again find the total derivative of w with respect to t, that is dw by dt. This will be the figure. F of x, y, z is a function of x, y and z. x, y, z are functions of the single variable t. So basically w will be a function of single variable t. It has only a single variable t. So you can find the total derivative dw by dt. We will be finding only partial derivative if there are two variables. But basically w or f of xy contains the single variable t. So you can differentiate w or f totally with respect to t. That is dw by dt. Or in other words, you can write this as df by dt, similar to the previous. dw by dt equal to df by dt equal to dou. Here there are three variables x, y, z. So the formula becomes dou f by dou x into dx by dt plus dou f by dou y into dy by dt plus dou f by dou z into dz by dt. So we are first differentiating f partially with respect to x into dx by dt plus differentiating f partially with respect to y into dy by dt plus differentiating f partially with respect to z into dz by dt. This is because f contains three variables and all the three variables are in terms of t. So this is our first chain rule. So you have to remember this diagram. F is a function of x and y. Both are functions of t. So you get df, you get the total derivative df by dt equal to dou f by dou x into dx. You have to by heart this formula. df by dt equal to dou f by dou x into dx by dt plus dou f by dou y into dy by dt. And if w equal to f of x, y, z, or if f contains three variables x, y, z, and all these three variables are functions of a single variable t, again you get the total derivative df by dt or dw by dt equal to dou f by dou x into dx by dt plus dou f by dou y into dy by dt plus dou f by dou z. One more term will be there, dou f by dou z into dz by dt, and this is the total derivative of w or f, w with respect to t. This is the chain rule. As w contains only single variable t, you can also find the total derivative by substituting, by direct substitution. You can substitute the values of x, y, z which are in terms of t, and then you can also differentiate w independently using the previous rules of differentiation, total differentiation that we will do in these two problems. We will find you the answer using chain rule, as well as we will find the answer using direct substitution. Both the answers will be the same. So by heart these two rules. The first one was two variables reduces to single variable. The second one was three variables x, y, z all in terms of single variable t. So you get the total derivative. Now suppose w equal to, these are two simple problems. W equal to x square plus y square, x equal to cos t, y equal to sin t. Find dw by dt. So here our w is x square plus y square in terms of x and y. X equal to cos t, x is in terms of the variable single variable t. Y equal to sin t, y is also in terms of single variable t. So this is our diagram f of xy expressed in terms of x and y. X and y are expressed in terms of t. So basically w is a function of single variable t. So you can find the total derivative dw by dt. Our formula is dw by dt equal to dou f by dou x, the first formula, dou f by dou x into dx by dt plus dou f by dou y into dy by dt. Now you know that dou f by dou x, this dou f or dou w by dou x, rather I feel this is safe, dou w by dou x, dou w by dou x into dx by dt plus dou w by dou y into dy by dt. So what is dou w by dou x? Dou w by dou x means differential of this. This is our w. Dou w by dou x is 2x. 2x into dx by dt. dx by dt, x is cos t. So dx by dt equal to minus sin t. So dou w by dou x into dx by dt means 2x into minus sin t plus dou w by dou y. Dou w by dou y, it is 2y because x is a constant. Dou w by dou y equal to 2y into dy by dt. Y is sin t. So dy by dt is cos t. So 2x into minus sin t plus 2y into cos t, or this is the same as, you can substitute for x. X is cos t, y equal to sin t. Substituting the values of x and y in this expression, you get 2 cos t into minus sin t plus 2 sin t into cos t. 2 cos t into minus sin t. This is cos t, x is cos t. So 2 cos t into minus sin t plus y is sin t, 2 sin t into cos t. You get minus 2 sine t cos t and plus 2 sine t cos t both get cancelled and the answer is 0. So you get dw by dt equal to 0. The total derivative of w in this case is 0. This is using, or we have found out the total derivative of w with respect to t using chain rule. Now the second method, by direct substitution. I am substituting the values of x and y in w. X is cos t, y is sin t. Put both these values in w, then you get w equal to x square plus y square means w equal to cos square t plus sin square t. W equal to cos square t plus sin, this x is cos t, y is sin t. So x square plus y square means you have w equal to x square plus y square, w equal to x square plus y square, but x equal to cos t and y equal to sin t. So w equal to cos square t plus sin square t, that is 1. dw by dt equal to 0. Differential of 1 is 0. So by direct substitution also you get the total derivative of w with respect to t as 0. Both these answers are the same. So this is our first problem. It contains, w contains two variables and these two variables x and y are in terms of a single variable t. Now come to the second problem. Suppose w equal to x plus y by z and x equal to cos square t, y equal to sin square t and z equal to 1 by t. You will get this diagram. W is a function of x, y, z. X, y, z are in turn functions of single variable t. That means w basically is a function, or it contains single variable t, or w can be expressed as a function of single variable t. So you can find the total derivative. The only thing is that w is expressed, or we can see w in as or in terms of three variables x, y, z, but all these three variables are what? They are functions of t. So basically w is a function of single variable t, and hence we can find the total derivative of w with respect to the single variable t, that is dw by dt, total derivative dw by dt. So in this problem we are finding dw by dt using chain rule as well as direct substitution. The formula for dw by dt is dw by dt equal to dou w by dou, there are three variables, so dou w by dou x into dx by dt plus dou w by dou y into dy by dt plus dou w by dou z into dz by dt. This formula, dou w by dou x, because w has three variables, so we have to find this dou w by x, dou w by dou y, dou w by dou z, and you apply the quantities in this formula, you get dw by dt equal to dou w by dou x. This is our w, dou w by dou x, differentiating this partially with respect to x, dou w by dou x. So you get 1 by z, y is a constant, z is also a constant. So when you differentiate this with respect to x alone, you get 1 by z into dx by dt. Dx by dt is 2 cos t into minus sin t, 2 cos t, dx by dt, 2 cos t into differential of cos t, that is minus sin t, that is minus 2 cos t sin t, plus dou w by dou y, again dou w by dou y, dou w by dou y, x is a constant, z is also a constant, so dou w by dou y is again 1 by z. Here it is only y, so dou w by dou y is 1 by z into dy by dt. Dy by dt is 2 sin t cos t. So 1 by z into 2 sin t cos t plus dou w by dou z. Dou w by dou z means x plus y is a constant, because we are differentiating with partially with respect to z. So since x plus y is a constant, the only variable function is 1 by z and its differential is minus 1 by z square. So the derivative, the partial derivative of w with respect to z, that is dou w by dou z, is minus 1 by z square into x plus y, that is minus of x plus y divided by z square, minus of x plus y divided by z square into dz by dt. Z is 1 by t, dz by dt is minus 1 by t square. So the expression becomes 1 by z into minus 2 cos t sin t plus 1 by z into 2 sin t cos t plus minus x plus y by z square into minus 1 by t square. These two expressions are opposites, plus and minus, so these get cancelled. Only this expression, the third expression, will be remaining. So you get dw by dt equal to x plus y divided by z square into t square. Minus minus becomes positive, so x plus y divided by z square t square. Substituting for x and y, substitute for x and y, you get x is cos square t, y is sin square t. So cos square t plus sin square t divided by z. Z is 1 by t, z square is 1 by t square. 1 by t square into t square. That is 1. Numerator is 1, denominator is also 1. So dw by dt equal to 1. So this is our total derivative dw by dt, which we found out using the chain rule, the second chain rule, this rule. Now we find the same answer, or we will get the same answer when we substitute these values and find the derivative. Now w equal to x plus y by z. You can substitute x is cos square t, y is sin square t, and z is 1 by t. So you get w equal to cos square t plus sin square t divided by z is 1 by t divided by 1 by t. Numerator is 1, denominator is 1 by t. You get t. So w equal to t. dw by dt equal to 1. These two answers are the same. So when we apply the chain rule, or when we find the derivative using direct substitution, you will get the same answer. So this is our first chain rule. You have to study this by heart, this formula. You have to remember these diagrams. In the first case, f was a function, w was function of x and y. There are only two variables, and x and y are functions, were functions of t. In the second case, w was a function of three variables x, y, z. All these x, y, z were functions of a single variable t. So in order to remember this, you have to study, or you have to keep in mind these two diagrams. And according to these two diagrams, you can formulate, or you can recall the formula, first formulas for the partial differentiating, or you can remember the chain rule in the first case. Now come to the second one. This is next level of second chain rule. Suppose w equal to f of u v. W is a function of two variables u and v. U is a function of another two variables x and y. U equal to u of x, y. V is also a function of two variables x and y. So w becomes a function of u and v. U and v are functions of x and y. So basically what happens, w becomes a function of two variables in contrast to the first one. In the first one, w was basically a function of single variable t, because all those variables were in terms of t. But here the variables u and v, w basically is a function of u and v, but these variables u and v are functions of another two variables x and y. So internally w becomes a function of two variables. W becomes a function of two variables x and y. You can see this diagram. W is expressed in terms of u and v. U and v are expressed in terms of x and y. So w becomes a function of x and y in this case. W becomes a function of x and y. So once there are two variables in w, you cannot find the total differential. You will have to find the partial differential. So we have to find the partial differential of w with respect to x, and we have to find the partial differential of w with respect to y. Just extension of the first form. There it was only one variable. Here there are two variables. There will be a small difference. If you are thorough with this result, you can easily by heart this one also. So w, remember that w is a function of two variables x and y. So the formula, the chain rule gives us dou w by dou x equal to dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. In the previous case, it was dou w by dou u into du by dx, because du by dt, because there it was only one variable t. But here there are two variables. That is why dou w by dou x equal to dou w by dou u into dou u by dou x. You can compare with this dou f by dou x into dx by dt. Dx by dt changes to dou by dou x. So dou w by dou x equal to dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. Now that is a partial derivative of w with respect to x. You know that w has second variable y also. So dou w by dou y equal to dou w by dou u into dou u by dou y plus dou w by dou v into dou v by dou y. So this is our next chain rule. Remember, w is a function of u and v. U and v are functions of x and y. So w becomes function of two variables x and y. You have to find the partial derivative of w with respect to x and partial derivative of w with respect to y. So dou w by dou x equal to dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. And dou w by dou y equal to dou w by dou u, you have to by heart this, dou w by dou u into dou u by dou y plus dou w by dou v into dou v by dou y. Now suppose I am extending this to the next stage, that is w is a function of u and v. U and v are functions of x, y, z. There are three variables in u and v. What will be our formula? If you by heart this, it is very simple. W equal f of u, v, u equal to u of x, y, z, v equal to v of x, y, z. Both u and v are functions of three variables. So basically w becomes function of three variables, x, y and z. W is in terms of u and v. U and v are in terms of x, y, z. So basically or internally w becomes a function of three variables x, y and z. This is not that much important. Just for the sake of extension I am doing that. We will be mostly doing problems of the first kind, the first one, two variables u, v, two variables x, y. So you just remember this. That is dou w. So we will have to find three partial derivatives, dou w by dou x, differential of w with respect to x, dou w by dou y, differential of w with respect to y, and dou w by dou z, which is the differential of w with respect to z, because w is a function of x, y and z. This is the formula. Just an extension of the first one, or this one. Dou w by dou x equal to dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. Now that is over, u and v in terms of u and v. Now dou w by the second partial derivative is dou w by dou y. Dou w by dou y is dou w by dou u into dou u by dou y plus dou w by dou v into dou v by dou y. One more variable is there, z. So dou w by dou z equal to dou w by dou u into dou u by dou z plus dou w by dou v into dou v by dou z. If you find something fishy or something difficult to remember this, you just study this. And if possible, you can extend this definition to the third one. That's all. We will be doing only problems related to this formula. That is this one. W is a function of u and v. U and v are functions of x and y. So w is a function of x and y. You have to find dou w by dou x and dou w by dou y. Now come to the problems. The first problem. Suppose w equal to u square plus v square and u equal to r minus s, v equal to r plus s. Find dou w by dou r and dou w by dou s. Look at the ray diagram. W is a function of u and v. W equal to u square plus v square. That is, w is a function of u and v. U equal to r minus s, v equal to r plus s. U and v are functions of what? R and s. So w depends on u and v. U and v depends on r. The two variables r and s. So in effect, w contains two variables, variable r and variable s. So we have to differentiate it partially, or we have to find dou w by dou r and dou w by dou s. W, uv is in terms of r and s. So w in terms of r and s. So dou w by dou r, dou w by dou s. Now come to the formula. Dou w by dou r equal to, look at this diagram and study the formula and try to understand the formula. Dou w by dou r equal to dou w by dou u into dou u by dou r, dou w by dou u into dou u by dou r plus dou w by dou v into dou v by dou r, dou w by dou u into dou u by dou r plus dou w by dou v into dou v by dou r. That is dou w by dou u. What is dou w by dou u? That is 2u. 2u into dou u by dou r. Dou u by dou r is simply 1, r minus s. So dou u by dou r is 1. 2u into 1 plus dou w by dou v. Dou w by dou v is 2v. 2v into dou v by dou r. Dou v by dou r is again 1. So 2u into 1 plus 2v into 1 or 2 into u plus v. Dou w by dou r equal to 2 into u plus v. That is 2 into, substituting for r and u and v, you get u is r minus s, v is r plus s. 2 into r minus s plus r plus s. S get cancelled. R plus r becomes 2r into 2, that is 4r. So dou w by dou r equal to 4r. The problem is not over. W is also containing s. So we have to find the differential of w with respect to s. So dou w by dou s. Remember the formula. Dou w by dou s equal to dou w by dou u into dou u by dou s plus dou w by dou v into dou v by dou s. You have to remember this diagram, then everything will be automatically you can understand this much more simpler, in a much more simpler manner. You can remember this. Okay, so dou w by dou s equal to dou w by dou u. Dou w by dou u is again 2u. Dou w by dou u is 2u. Dou u by dou s, dou u by dou s, r minus s, that is minus 1. Dou u by dou s is minus 1, so 2u into minus 1 plus dou w by dou y and dou v. Dou w by dou v is 2v. 2v into dou v by dou s. Dou v by dou s is 1. Dou v by dou s is 1. So 2u into minus 1 plus 2v into 1, that is 2 into v minus u. 2 into v minus u. Here there is one minus. Here only v. So 2 into v minus u. 2u into minus 1 plus 2v into 1 equal to 2 into v minus u. Substitute for v and u. You get v is r plus s minus r minus s. R get cancelled. S minus minus s, that is s plus s, 2s. 2 into 2s, that is 4s. So dou w by dou s equal to 4s. So w was a function of u and v. U and v are functions of r and s. We found out two derivatives, dou w by dou r, that is 4r, and dou w by dou s, that is 4s. You can see these questions in the question papers also. There are many other problems. This is seen in the Calcutta University question paper. You can verify it. Now come to the next problem. This is somewhat a lengthy problem. So I will be doing only one part of it. Rest I have mentioned it here. You can try it yourself. Now w equal to sine 2u minus v. W equal to sine 2u minus v, where u equal to x plus sine y, v equal to xy. W equal to sine 2u minus v, u equal to x plus sine y, v equal to xy. Now what happens? Find dou w by dou x at pi 0. Find dou w by dou x at pi 0. What happens here? W is a function of u and v, as usual. W is a function of u and v. Both u and v are present. W is a function of u and v, that is w equal to sine 2u minus v. U equal to x plus sine y, v equal to xy. So u and v are both functions of what? U and v are both functions of the variables x and y. So basically this is our w. W is in terms of u and v. U and v are in effect terms of x and y. So w becomes a function of x and y. So we have to find the two derivatives, two partial derivatives, dou w by dou x and dou w by dou y. But here it is only asked find dou w by dou x at a particular point pi 0. So we will try to do it. First we write the formula. Listen, remember w is a function of u and v. U and v are functions of x and y. So dou w by dou x equal to dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. Dou w by dou x is dou w by dou u into dou u by dou x plus dou w by dou v into dou v by dou x. Finding these values, dou w by dou u is cos 2u minus v, cos 2u minus v into differential of 2u, that is 2. So 2 cos 2u minus v into dou u by dou x. Dou u by dou x is simply 1. Dou u by dou x plus sine 2y. So dou u by dou x is 1. So 2 into cos 2u minus v into 1 minus dou w by dou v. Dou w by dou v is, dou w by dou v means cos 2u minus v into minus 1. Cos 2u minus v into minus 1, that is minus cos 2u minus v. Because it is here it is minus v, so its differential is minus 1. So dou w by dou v is cos 2u minus v into minus 1, that is minus of cos 2u minus v into dou v by dou x. Dou v by dou x, dou v by dou x is simply y. Dou v by dou x is y because v is equal to xy. Y is a constant. X is only variable, so its differential dou v by dou x is y. So dou w by dou x equal to 2 cos 2u minus v minus cos 2u minus v into y. In the next step, I am substituting the values of u and v in this expression. simply substitute the values of u and v in this expression. Then you get 2 cos 2u is the same as 2x plus 2 sin y. You should be extra careful. Please zoom in on this area so you can understand it more clearly. So 2 cos 2u minus v, 2 cos 2u is 2x plus 2 sin y minus v is minus xy minus cos 2u minus v minus cos 2u is again 2x plus 2 sin y, 2x plus 2 sin y minus v minus xy, here it is minus xy, 2u minus xy into y. So 2 cos 2x plus 2 sin y minus xy into minus cos 2x plus 2 sin y minus xy into y. Now once you substitute the values of x equal to pi and y equal to 0, we have to find dou w by dou x at pi 0. So put x equal to pi and y equal to 0. When y equal to 0, this whole term becomes 0. This whole term becomes 0 when we put y equal to 0 because it is into y. This quantity into y. So this becomes 0. Now when we put x equal to pi and y equal to 0 in this one, you get dou w by dou x equal to 2 cos 2 pi x equal to pi. So 2 cos 2 pi, this is 0, and this is already 0. So dou w by dou x equal to 2 cos 2 pi. Cos 2 pi is minus 1 whole square, that is 1. So that is dou w by dou x equal to 2. Dou w by dou x at pi 0 equal to 2. It is a bit lengthy problem. You have to be careful while doing this. When you are substituting these values and all, you should be careful. Now one more problem is there. Find dou w by dou y at pi 0. This is also, you can do it as a homework. Find dou w by dou y at pi 0. So in the similar fashion, dou w by dou y is dou w by dou u into dou u by dou y plus dou w by dou v into dou v by dou y. Substituting these values, you get this one, and substituting for u and v, putting x equal to pi and y equal to 0, you do it as a homework. This you get the answer as dou w by dou y at pi 0 equal to 2 minus pi. You can verify this. You can do it yourself. This one, dou w by dou x at pi 0 is 2 and dou w by dou y at pi 0 is 2 minus pi. So we have applied only the first part of this formula. W depends on u and v. U and v depends on two variables x and y. In both these problems, this formula was applied. And I have told you this is not that much important. You can try. If you get some problem related to this one, you can try it from home. Now, we will stop here for now. In the next video, I'll be taking the next stage of chain rule. So, just a revision. In the first case, W was a function of two variables x and y. W was a function of two variables x and y. X and y was a function of single variable t. So, we got the first formula. Now, in this one, W was a function of three variables x, y, z. X, y, z all were functions of a single variable t. All were functions of single variable t. Again, you got the formula for total derivative using chain rule. But in this case, W was a function of two variables u and v. U and v were functions of two variables x and y. So you get the second chain rule. This one is an extension. I am not mentioning it again. So these three rules, the first, second, and this one, it is very important. You have to do as many problems as you can, because once you study this, you will have to memorize it. You will have to remember it every now and then. Otherwise, you cannot recall it when doing problems or while examinations. So you can find many problems in the backside of your textbook or exercises. Practice it, minimum 10 problems of every chain rule you have to practice, then only you can remember it. So I am stopping here. In the coming videos, I will be discussing higher forms of chain rules. Thank you.